In lesson 78, we look at force vectors at a point. So I've drawn the kind of pulley system, even though it isn't exactly like your book. Hopefully it'll give you the right idea of how we would add these two vectors. But the first example states, two ropes are attached to a point and pulled on with the directions and magnitude shown. What is the resultant force on the point? Alright, so we have our magnitude, the 70 and 40, and then we also have our direction of 45 degrees and 30 degrees. Think about these being like on an XY axis. And that'll kind of help us to figure out what's going to be positive and what's going to be negative. So first, I would set this up as adding two vectors. So I would say 70 at a direction of, I'm going to use 135 degrees, because if this was the y and x-axis, the relative angle would be 135, because this angle here would be 180, and you would just subtract the 45. And then that would be added to 40 at an angle of 30 degrees, because that would be in the first quadrant, and this would be in the second. And then we use our standard format that we've been using, 70 cosine 135 plus 40 cosine of 30 degrees, and then 70 sine 135 plus 40 sine 30 degrees. So in this first one, I would get a negative 49.497, and I would add that to 34.64, and that equals negative 14.86, and that is the R value, which relates to the X. And then for the next one, we get 49.497, and that would be added to 20 for 69.50 for rounding, and this is related to the Y. Then we would write this out in standard form as negative 4.86R plus 69.50U. Now this is the rectangular coordinates, and what they're looking for with the resultant force is polar coordinates. So we're going to have to change this back into magnitude and angle. So if I was to graph that, this is a rough sketch of it, we would have a negative 14.6 somewhere over here, and then 69.5 somewhere way up here. So this would be the 69.5, and this would be 14.86. So we need this angle and this magnitude right here. So to find the angle, we use the tangent because we have the adjacent and the opposite side. So I would say theta equals the inverse function of tangent of 69.5 over 14.86. So theta equals 77.93. Now if we just went with this angle here, that would be in the first quadrant, but as you can see, this is actually in the second quadrant, so we actually need to subtract that from 180 degrees. So 180 plus 102.07 degrees. Okay, so this is going to be the angle that we need to use in order for this to be in the correct quadrant. This is the angle we want right there. Alright, and then to get that magnitude, just use the Pythagorean theorem. So our magnitude equals the square root of 14.86 squared plus 69.5 squared, and that gives us approximately 71.07. Alright, then for your final answer, you want to write this as 71.07 at 102.07 degrees. Alright, so these are not necessarily horribly hard, but there is a lot of work to them, okay? So please show work on these problems. In the second example, we have a point that's acted on by a push force and a pull force. So the 10 here is the push force, and the 16 at an angle of 30 degrees is the pull force. And the 10 would actually have an angle of 0 degrees. So you could write that as 10, 0, and then this one here is 16, 30 degrees. Okay, so those we are adding together, and you can actually rewrite this with the 10 down here because our point right here, let me put that in another color here, because our point right here cannot tell the difference if it's got the 10 at 0 degrees pushing or pulling. It's going to feel the same thing. Okay, so if you want to, you can redraw that here. So these are the two vectors that we're adding together, and it works out nicely because this will put them both in the first quadrant. So this is pretty simple. It just ends up as 10r plus 0u for the first one. And that is a u. There we go. But for the 16 at 30 degrees, we have to find the r and u. So we'd have 16 cosine of 30, and then 16 sine of 30. So the 16 cosine of 30 is approximately 13.86, and the sine of 30 is 8. So we can add these. This would be 13.86r plus 8u, and then we can just add straight down. So this would be 23.86r. Do my addition here so we don't forget what we're doing. Plus 8u. Now that's rectangular coordinates, and remember, for the resultant force, we want this in polar coordinates. So we need the angle and the magnitude. So for the angle, or theta, it's the inverse function of tangent with 8 divided by 23.86, which is approximately 18.54 degrees. And then for the magnitude, we use Pythagorean theorem, so 23.86 squared plus 8 squared equals approximately 25.17. So to write this as our final answer, we would have 25.17 at an angle of 18.54 degrees. and then that would be our final answer for the resultant force on number 2. Hopefully this will help you. If not, feel free to ask any questions.